In this ACT video, we're going to review slope of a line. So here I've got a line graphed for you, and it has a certain slant to it. And that's what slope is. You may be familiar with the formula for slope, and you might be familiar with what's called rise over run. First, let's take a look at this graph and talk about the rise over the run. That's basically what you would use to find the slope of a line looking at a graph. So to use rise over run, we'd need to pick out a few distinct points on this graph, like this one, maybe this point here, this point, and this point. We'd start with our lowest point, and we want to climb up the line. To go from this lowest point to the next point, we have to rise up 1, we run to the right 2. So our rise is 1, and our run is 2. So our slope is 1/2. And we can keep doing that. Rise 1, run 2, rise 1, run 2. And it's consistent. The slope is the same. Because we're running to the right, our slope is positive. If our slope of our line is pointed in the other direction, then in this case, the slope is always going to be negative. Now, we can use rise over run when we're talking about a graph, but what we might want to use given 2 points is the slope formula, which is y minus y over x minus x. So when given 2 points, we'll use this formula right here. And remember, we're using that lowercase m to represent slope of a line. So let's take a look at an example using the formula. Here we've got the 2 points 5, -2, and 0, 1. And we need to find the slope of the line that's passing through these 2 points. So what you might want to do, especially if you're new to the formula, is you might want to label this x1 and y1 and x2 and y2. Those little numbers at the bottom, those have no mathematical meaning. Those are just subscripts or names. That's just saying 5 is the first x and 0 is the second x. Now your formula is y minus y over x minus x. And we use the subscripts to distinguish that we need to pull our y from the second ordered pair, so we also have to pull the x from the second ordered pair. So whatever you do first for the y, you must do it first for the x. So the easiest way is just to label it y2 and y1 and x2 and x1. So we're ready to plug in. We've got everything labeled, which makes it easier. So in the numerator, we've got y minus -2 divided by 0 minus 5. Well, using our integer rules, a minus and negative changes to a plus. 1 plus 2 is 3. Over 0 minus 5 gives me -5. So we say our slope is -3/5. Let's take a look at another example. Here we have the 2 points 4, -2 and -7, -2. So we're looking for the slope of the line that passes through the given points. Again, I recommend just labeling them. Makes it a little bit easier. And that way you don't get things mixed up. Write our formula. Slope is equal to, sometimes we say change in y over change in x. That's another common way to say this. Ready to plug things in. In the numerator, we get -2 minus -2 divided by -7 minus 4. Y minus y over x minus x. Minus a negative changes to a positive. -2 plus 2 is 0 over -7 minus 4 is -11. 0 divided by -11 is 0. So the slope of this line is 0. And that actually means it's a horizontal line. So if we were to graph those 2 points, just a quick sketch, here's -7, -2, and here is 4, -2, And that would be the horizontal line that passes through y equals -2. A horizontal line has a slope of 0. It's like walking on the ground or on a treadmill with 0 incline. So you may recognize that by looking at the ordered pairs and seeing that their y coordinates were exactly the same. Let's take a look at another example. Here we have the ordered pairs 1, 9 and 1, 5. Label this x1, y1, and label this x2, y2. Write your formula down. Change in y2 minus y1 over x2 minus x1. We'll plug things in the numerator. That gives me 5 minus 9 over 1 minus 1. 5 minus 9 is -4 over 0, and you cannot divide by 0, so now our slope is undefined. And this is kind of a special case also, just like the slope being 0. If I were to graph these 2 points, you can see here's x is 1. Here's, let's say x is 5 is right about here, and x is 9 is right about here. Here's the point 1, 5, and here's the point 1, 9, and that is a vertical line. So a vertical line has an undefined slope. That you can't climb up that, you can't walk up that. So that slope is undefined. You may have recognized that because you see your x coordinates are both 1. Now, a couple more things we need to review with slope. Remember, slope is the amount of steepness or slant that the line has. Okay, it's like walking up a hill or maybe the roof line of a house. And parallel lines have the same slope. Okay, they have the same exact slope. They never intersect, but algebraically speaking, they have the same slope. So looking at these two equations, we have y equals 3x minus 1 and y equals 3x minus 5. And remember, from a previous video, we know y is equal to mx plus b. So that coefficient of x is our slope. So the slope of this line is 3, and the y-intercept is -1. And the slope of this line is 3, and the y-intercept is 5. So because these two slopes are the exact same, these two lines are parallel. Now, perpendicular lines, algebraically speaking, perpendicular lines, they intersect at right angles, like a cross or a T or a plus sign. Algebraically speaking, their slopes are opposite reciprocals. Opposite means different signs. One's a plus and one's a minus. And remember, we kind of just say reciprocal means flip it over. So looking at these two equations, y equals 1/2 x plus 4, the slope of this is 1/2, and y equals -2x minus 7, the slope here is -2. The slopes are opposites because this slope is positive, this slope is negative, and the reciprocal of 1/2 is 2. So these lines are perpendicular because their slopes are opposite reciprocals.